Welcome everybody. This is our 5th modding bootcamp. This one's going to be on replication fundamentals. Replication is one of the most commonly misunderstood aspects of modding, and so we hope this will help you get started with some of the basics and principles. With that, I'd like to introduce Remy Simonin and Mario Enriquez. Take it away, boys.
Hello everyone, I'm Mario. Hello everyone, I'm Remy. And today we will go over the replication fundamentals of Arma Reforger. We will start slowly with how the replication is done, and we will then go on how to replicate the things that you want to replicate. Okay, so we are already in Workbench, in Everon. First, we will see how we actually replicate things in the game. So for that, we have something called the scheduler, which is actually telling from the server side, it will tell to the clients what needs to be replicated. We will go in game and I will show you directly how it works. So the scheduler is actually working in a way that he has like some grid map, so some grid, and in each of those cells of the grid, it's actually like the list of entities that he needs to replicate. For displaying it, we have actually a diag for that, which is in game code. You have the diag, you have network. Then here you have like a replication scheduler. Inside it, you have like a server-side replication scheduler. And then here you have exactly like the spatial map. It will actually show you the spatial map that we're seeing here. It's actually showing you the cells, so each of cells of the map, and it will also show you the entities that are replicated with the orange bonding box. Each cells have a color. This color is based on the number of entities inside. So if there is almost no entity, it's green. And if there is more than 512 entities, it will actually show red. This helps like to be able to see which cells have actually a lot of entities, and maybe for setting it up later, the size of the cells, depending on your map, you will be able to see that. We can see it here, for example, if I go in the city somewhere here, we are actually in experimental, so we are in 1.3. We have all the destructibles enabled, so buildings and trees and everything, almost. So you can see if you go around that you will actually see all the entities. Like if I go inside the interior, I'll see every entities that are actually replicated. For the streaming, how actually it works is that the server will take whatever client, for each client, it will go over the list and it will check the position of the client, and depending on this position, it will actually streaming around depending on those cells. So based on that, if you have bigger cells, it will actually stream. If your cells are bigger and the size of the number of cells is, for example, 2, and the size of the cells is 1 kilometer, it will actually stream 2 kilometers. Of course, like there is always a trade-off. If you have smaller cells, it will actually have less entities inside, but it will be more processing for the server and also more memory for the server because it needs to keep track of all these cells. So of course, there's always a trade-off when you set up those cells to define like the size of them. Most of the time, what we do is that we try to, for Arma Reforger, we found out this size of cells is actually very good. But of course, you can always, depending on the map, for example, if you have like a smaller map, you can have like smaller cells than bigger map. For setting it up, actually, the cells, it's actually on the command line parameters of the server or the application. Here we have a workbench, so we have like a full own CLI. So on Steam, here I'm using Steam. So on Steam, you can go into the properties and you can set up like the launch options. Most of what you will use is NDS, which is the number of cells that is streamed in. So for example, here I put 1. So that means I can see like 1 cell away. And then there is the other one, which is network resolution. And it will actually tell the size of those cells. So here for the demonstration later, I will actually reduce it specifically so we can see it easier when I will show you when it streams in and stream out and everything. So for example, here I set my cell size of 10 meters. This is in meters. So I will just stop the application. I will restart it. For this example of how to actually our replication work, we will go over like the model of replication, which is authority, ownership, and proxy. I will go into my MP test. So how we have this we have this model of authority, ownership, and proxy, and how it works is that we have one authority which define the game. For example, if you have dedicated server, it will be the dedicated server. If you host your server, it will be your application that will actually be the authority. So it will be you. We have ownership, which means the ownership is the idea of that some entities can be controlled or can be by somebody else, so not the authority. So for example, if you have characters in the game, those characters are actually moved by some client, some people on the server, and just the server will actually like give the ownership to them. And we have the proxies, which is actually the other things that you get streamed in. So for example, if I am a player, everything I'm seeing around you are almost proxies, because that's like the view of the server. Like this is the server state that you view afterwards. So, for example, we have like typical example with Mario is talking on stage. So if you have someone that is actually hosting something, a stage, it will actually be the authority because that's him that actually hosting the stage.
Yeah, we can take as example, for example, what we are doing right now. The authority at this time is Evan, as he's the main one that was hosting it. You know, he was the one that initiated in. So he is still the authority, and he just gave me and Remy ownership, you know, like of the stage. So in this case, the authority of the stage is Evan, and I have ownership on it right now, so I'm able to speak to all of you as well, to send the data to the Discord server that then you receive, for example. So if, for example, I decided to that, for example, I don't want to talk anymore, you know, I can send some notification, you know, some RPC or whatever to Evan, and then Evan is going to receive it as the authority, and then he can decide if he gets rid of my ownership and gives it to someone else. Like I don't know, it could be Emmanuel here as well, so that he can also start speaking of something or whatever. And that's basically kind of like the idea of ownership and authority. You have someone that is the proprietary, of the stage or the entity or the component, etc. This model is not only for entities. It applies to components. It applies to game systems. It applies to what we call in the replication system as replication items. So that's what a replication item means, basically. And a component is a replication item, a system is a replication item, etc., etc. And the proxies in this analogy that I was mentioning, that we are doing currently, all of you are the proxies. So you are getting broadcasted what we are discussing on that. So that's basically the idea. There is a single entity in this case, which is the stage, and we are just messaging through this. So for example, let's say that we have another entity or another item in this case, which will be, for example, the stage chat. In that one, that's basically another entity. So that also has another authority. That also is like an authority of like whoever manages the Discord server and all that. So that's basically the idea. You have entities, and these entities or components, they all have like kind of like their own replication state. So the owner of one entity might not be the same owner of another one. So in this case, you need to be a little bit careful because this changes a little bit of how you decide if you are a client or if you are a server. So like you could be server and client. So it's better if you follow like this model that we are discussing about. In this case of this replication bootcamp, we will not go too much into detail on how to differ, if you are an actual client or if you are a client on a server or if you are a headless client, etc. That will be in the next replication bootcamp. But the general idea that we want you to get right now is kind of like the difference of what is a proxy, what is an owner, and what is an authority. So hopefully with the analogy is a little bit clear. So now after this, let's go with the example, of how to do RPCs and synchronize state and all that.
Yeah. So to communicate in the game, we actually use two things. We have the first one, which are RPCs, which are messages that sends between the client and the server, or the other way around. And we have RPL props, which is another way of communication. For this example, we will actually use some door that we have set up. This door is actually some animated entity with some component with some RPCs and everything. So first, like RPCs, they are actually have two ways. We call them channel. You have reliable RPCs and unreliable RPCs. So the idea between reliable and unreliable is that reliable is guaranteed to be delivered. It's written here. So that means that if you send the message, you are guaranteed that it will always arrive on the other side. Where unreliable means that it will not. So if you have packet loss or whatever can happen on the network, it will not be resent, so you will never receive it. In most of the cases, you will probably use reliable, but if you want to create, for example, in the game we have characters, those could use unreliable because we send position every every frame, for example, of the character. So we don't need to be sure that the other side received it. We can just be unreliable, and we are not sure if it will receive, but the next time it will actually receive. And then we have receivers, of course, for the RPC, because you define if the RPC is targeted for the server, for the owner, or if it's a broadcast. As we said before, we have the authority, which is the server in this case. So you send a message from the from client, for example, to the server. You have also the owner, so you target specifically this message to the owner of this instance. And you have the broadcast. The broadcast is that you want to send something to everyone, including the owner. So if you want to send, yeah, exactly. If you want to send a message to everyone, you send a broadcast. Those are very specific, of course. Here there is the table, which is exactly like when the RPC will be dropped or not. Specifically because, for example, broadcast can only be sent from server, from the authority. So only the authority can send the broadcast. And to the owner as well. It's only the authority that can do it. From client to the server, it only works if you are actually the owner. If you can see it here, it's actually, if we are the owner, then the call is sent to the server. If we are not the owner, it's dropped. This is the whole principle of the model, is that you have only one client or one machine that have like the ownership, so it can send data over to the server. Afterwards, we have the RPA prop. The RPA prop is some way to communicate, but this is states. So that means that you send data over the network from the authority to the client. That's only one way. This is like broadcast, technically, like RPCs. The thing is that this is not reliable. This is complicated. This is like the state that you set up. It's a state. That means that you don't need to be ordered and always received to the other side, but you want the last state to be received to the other side. So that means technically it's not reliable, but you still have the thing that the last state will be correct on the client. I will show you an example. It will be easier because otherwise, like it's a bit more complex. So imagine that we are on the server, and we have, for example, this open value, which is the open of the door. And this open value on the server, we set it up to 0. This open value is between 0 and 1, which is 0% open, 100% open. And if we put this value to 0.5, for example, which means 50% open, and the next time, instantly after, we put to 100%, if we use RPA prop, it will actually, it could be dropped. So that means that you maybe will never receive the 50% one on the clients, but you are sure that you will always receive this 100% one, like the last state that was set up. So this is very specific. This is most of the cases you will use this because you want like some states or something that is like that you want everyone to be aware of, but you don't want to send RPCs all the time. So we have the other variant, which is RPCs. As I said, here, if we do exactly the same example, so we go to 50%, we send the RPCs, and then we go to 100%, and we send our RPCs. On the client, it will always receive those two RPCs ordered. So it will always receive the call to this method first time with 50%, and then the second call of this method, 100%. So this is the differences, and this can have, of course, huge impact on how you do your thing. And yeah, this is the mostly like ways to actually send messages over the network. We were speaking about ownership all the time, and we were saying that you can give ownership to a client. For this, we have specifically a method on base RPL component, which is give. This can only be executed, of course, by the authority, as Mario said. And this says that you want to give the ownership of this specific entity to a specific client that you pass, which is the replication identity. This will send a message over the network, and then the client will have the ownership. For this example, we will go over it. So for this, we actually have set up a gate, so a door, and we will go over like the typical implementation that you will do for this replication of the door. So the first one is our RPC. So what I will do is like I will set the percentage to 100%, so open. I will send the RPC. This is exactly here. You see, I have a method which says set open. I put 100%. I call the method on myself on the server because this is only server. And then I send the RPCs to everyone variably, which means that everyone will always have these RPCs. And depending on the state, if it's changed, I actually set the state to 100%. And then that I call this method onOpened, which will play a particle, a smoke particle in this example. And then I have this specific part, which will be covered in a future modding bootcamp for animation. But here what we do mostly is just that we send this variable to the animation so it can play the animation. If we go here, so how do you do multiplier in Workbench? Because most of the time you will want to debug it or try it. So for that, we have two tools. We have the first one, which is ptool, which will actually create instances of the game, depending how many instances is how much you want, you set it up. So here, for example, if I see like this is I put the diag.exe first. I create an instance of my ptool and I set it up whatever I want. The most important is that you can set up some debugger port here, which will help you for debugging clients, because in the script editor, you will be able to set up a specific port. Like here, if we go to debug, here you see you have like debug workbench, which is the current instance. But if you want, you can put debug custom. And here you can set up like the port that you want to debug. So you are being able to debug script on the client and not only on the server in this case. And the other tool that we have is the dedicated server tool, which here will actually start a dedicated server for you and some client, which peers, we name it peers. So it's mostly the same here. We set it up like the executable. So this is the server tag. And we set up the debugger port again, so we can also debug the dedicated server. It's not only to clients. And here we set up also a client. So if we try it, this implementation of RPCs, we will see specific use case. So if I go here, I will wait until it loads. I will also, for this specific I need my remote consoles. And for this specific thing, I will, here how we set up this is just for opening the door. This is simpler for us to actually like to use in for this demonstration. Of course, like you can put a user action or anything and call it on the server. This is not like the topic of this. The topic of this is like the replication itself. So here I just set up some remote consoles that you can use in Workbench script editor, and it will make you being able to execute scripts on the debugging instance that you do. So that means, for example, In this case, I'm the server, so I will execute in the server. But if you debug a client, you can also execute code on this specific client. Here, so I will just execute. You can see, as we expected, the door is opening. It has some animation, and it will play some particle. Then, if, for example, in the game, we go very far away, like kilometers by default, and it got streamed out. This is like the typical term that we use, stream out and stream in. Stream out means that the entity on the client will be deleted because the server thing that says that you should not have this entity anymore because you are too far away. So it will stream out. That's what we call it. And we have the other way, which is stream in, which means that if you are close enough to an entity, the server will tell the client, hey, create this entity on the client. So here we can see that I put, for this example, I put 10 meters. So I am like 20 meters away, and I don't see the door anymore, neither the character. If I come back near the door, we can see the issue is that I just sent one RPC over the client, but when I come back and this entity is created again, it will actually not save the state. It will not send the state to the client. So here, my door is closed, but if I look on the server, my door is open. And this is the typical this is one of the desynchronization that you can have, is that you didn't send the state correctly to the client. So here we have like pretty much desync, and this is how it hands if you send only an RPC. We have another version, of course, because when you are in this case, you are like, okay, but now how I actually save the state and give it to the client. For that, we have another version, which we names RPC save and load, which replication gives you some callback, that you can override. Those callbacks are actually called automatically on the component. Of course, it's called if your component have some properties on some RPCs, right? Because that's the point. So here I have my RPC. Here I have like save and load. And what I do in this component, so it's the same as before, the RPC1. So I have an RPC, but here I have another component which overrides save and load. And here, what does those callback is that the save is called on the authority when you want to stream in an entity, and RPL load is called on the client on the other side when it needs to load this entity. And here, this is like a buffer, so you can write whatever you want in it to save the state. So here, for example, what we do is that we find the other component and we write the state. So we write this float, which is 32 bits. So we write into the bit buffer 32-bit the state of the gate. And here on RPL load, we actually read it and we set the state to this. So this float. So now if we try again with this setup, so I will just disable this one. Also, a typical case that you can happen is that you placed an entity. For example, here I placed a gate on the map, but it will not. If you start the game, it will tell you like there is an issue because the world is not the same. This is mostly because caching of entities. So when you place an entity in the world, which is a replicate, like place an entity in the world, the best is to reload the world afterwards, or at least before you play in multiplayer. So it's like correct and the cache is correct and everything. So here we'll do the same again. So I will connect and what we will do is that I set some. I will check the debugger port that I set, and I will put a breakpoint to show you like how you can debug. So this is like 7777. Here I will play. In the script editor here, I will go into debug custom, set 7777. Then you see the script debugger is connected, and I will put a breakpoint in this, which is like the callback, which is called when the RPC happens. So we will go again. I need to actually change the workbench to remote console, I think. Where is my remote console? Okay.
It's probably behind the game window.
Maybe if I do this. Okay, we are trying to find the remote consoles that disappear for some reason. What I will do, I will just restart the script editor. I think it should be okay. Yeah, no, it's back. So I set it up to workbench. I run. Here we can see that the door is open again. Here I will go into debug, go to the client. So I'm connecting to the client. This is correctly like created. I go to the client. I see everything. I see this beautiful thing. I go away slowly but surely. Yeah, and I come back. And then here you can see that the breakpoints actually open, and it will read the state of the gate. So now, if I look at it, the gate is open. The thing is that we will redo it again. I will remove the breakpoint, and you will see one of the issue that can happen as well, that most of the time can happen, is that what you will have is you will create some animation, for example, for opening, and you can see it here that every time I stream it in, it will actually play the animation all the time. So this can be animation, but it can be, for example, sounds or stuff like that. That means you didn't do the thing correctly, because when you replicate the state, it should be instant. It should not play any sounds. It should not play any particles. It should be like the current state on the server. For doing that, we have created actually another example for this. So if I take this one, so I remove this one, and I put this one, which here we have done a bit more than before. It's almost the same as before. It's just that here we are actually, if I put again the correct order, personally I prefer to put, almost all the time we put like the save at first, because this is how you read the code. This is how it happens. So you have like the save first and then the load on the client. So you have like the same thing. It's writing the state of the door, but here the difference is that here I'm actually reading the state, exactly the same, but here I put a specific Boolean which says should call instant. This what actually happened is that here you can see that when we doing the animation, we actually like define if we should call instant, we should call like a command that will actually instantly do the changes instead of playing the animation. So if we do it again, we go to the server, we launch the game. Same thing. So we have this. I will just go into Workbench. I will try to find my window again, of course. Yeah, here. And I will run. Yeah, this is the same thing exactly as before. We actually play the animation and everything. Then we go away, streams out, and then we stream in, and now it's instant. So you can see like the door doesn't play the animation anymore, but it's instantly there. So this was the implementation with RPCs. As we said before, there is also RPA prop, which is a state-based. So for that, we have other gates to do that. So most of the time, what you will do for this is that you will create RPA prop with the state. So if we go into this version, which is a new one, which is almost the same as before, this RPA prop variant, the only difference is this open variable. It has like RPA prop attribute on top of it, which means that it will automatically replicate.
Yeah, and the callback, which is...
Yeah, of course, you can define for this RPA prop. If we go here, you have like multiple definition. The most important one is the on RPL name, which is the replication. When it will replicate, it will automatically call this method for you. And you have, otherwise you can anyway take a look at the documentation that we have of replication, which also shows other like very specific parameters of this RPA prop. The most important is on RPL because that's the one that you will use. And also the condition, of course, which is if it's owner only, not owner, or custom for custom conditions. In this case, how we set it up is that we have almost the same as before. We have this set open method, which do almost the same as before. What it changes is that it calls this replication bump me, which is this method that you need to call when you change RPA prop and you want to send this change to the clients. Of course, this is not one-on-one. If you want to do some optimization or something, you don't need to call it if you don't want to send it to client. But most of the time, of course, if you change a value on the server, you will want to be replicated to the clients. So for that, you use replication bump me, which will automatically tells the replication, hey, I actually change a value here. Please send it to the client. And we have almost the same thing here where we set the variable, the state of the variable. So if we go into this, we save, we reload, and we play, we will have almost the same thing as before. Here, what I will do is that I will use this, and I will just change the name of this and using this. So here we have the specific thing, which is it's exactly what happened before. So we opening the gate, the particles play. Now if we go away, then we come back, you see that exactly what happened is that first is the animation of the door and also the playing of the particle. And this is because when we created this component, we just set RPA prop. So that means every time a client gets streamed in this entity, this on open method will be called, which means it will actually spawn the entity. Plus setting this variable, of course, but this is automatic. You don't do it yourself. Yeah, I forgot also as well that replication bump me only happens that you should always use it on specific entity or specific class that you want to replicate. If you try to use it, I don't know, somewhere else, it will throw you an error saying, hey, you can't use a replication bump me here. You should always use it in the class that you want, the class that you want replicate. You can't pass like any variable or anything. You really need to use it only here. And if you misuse it, it will always tell you like an error saying that you should not use it here. So we have another variant, which is the appear prop and RPCs, which here we will actually combine the two methods. So the state, which is appear prop, and the RPCs to send a message. For that, we actually, so how do we did it? Is almost the same as before. So we have like the open variable, we have the appear prop, and we have this set open method. Here you can see that we are actually sending the RPCs the same as before. This RPCs, which is reliable in broadcast, we send it to all the clients broadcast, and we change the percentage. We call onOpened, which will play the particle effect. And if we actually do thing, which is that we set replication bump me, which in this case, what we do is that we set the percentage and then we say, hey, all the people, you have this, please synchronize this variable over. Please server, please replication, synchronize this variable over. I'll just reload the word just to be sure. And we will try it and we'll see what happens. So if we do this, we go to the server, we'll just run this. Oh, yeah, I forgot. I need to change the name of this thing. So I will take this, I'll run it. Yes, I'm on the client. You see first that it didn't like played some particle. So this is the thing, and also it's actually, I mean, it opened the door, of course. Now, if we, I will go a bit deeper why it actually did not play the particle, because you will probably think why it didn't play the particle. If we put a breakpoint here, because as you can see, what we do is like we set up this variable, we bump it, and then we send an RPC. And what actually happened here is that the replication of the state arrived before the RPC. So when we arrived in this call, this open perk and a percentage is both 1. So that means it will not go into this method, of course, because like the because they are all both 1. You need to be aware that in this specific case, it happened like this. But of course, depending on the network, it can happen that it will be the other way around. The RPC will arrive before the state. So it's not, in this case, it happened like that. But of course, like it's not like made like that. It's like depending on the network. So if we go away and we will come back. So we do this and we come back. You see, it's playing the animation. And you are probably, so it's normal that it play the animation because we don't have like the instant thing that we found out before, like I shown before. We didn't create a like specific one, but it correctly synchronized and it didn't play the particle. That was the most important thing. If we want to actually make it work, because as you saw before, like when I opened the door, it actually did not play the particle correctly. And this is because we used replication bump me in this case. So here, if I remove this replication bump me, because I'm saying, hey, I'm sending an RPC over the network to broadcast this variable. So I don't need to send a state again over the network. What I want to do is that in case someone's streaming in this entity, then it will use the RPL prop directly, because that's the state. It's always synchronized. So in this specific case, I'm saying, as I said before, I'm saying like, don't stream the state. Don't send the state immediately. Just don't send the state. So if we go, I will just recompile just to make sure I don't know if I recompile. So yeah, I play, I go here. Exactly, so I did this, I'm here, I will go here, I will play the animation, and here now I have the correct like particle playing. Now if I go away, and I go back, yes, so it's playing. Yeah, of course, as I said, like we didn't implement like this instant thing, but it's not playing the particle. So it's exactly the correct way. So now probably you will ask, most of the people will ask, okay, but this is two technique and they do almost the same thing. There is the RPC1 with save and load, and I have the RPL prop one with some RPC. Which one to use? Most of the time, you will want to have states of things to be RPL prop. Why? Because you don't want to order the RPCs. Like if the states change quickly, you don't want to send like this, RPCs over and over and to everyone all the time. This is costly. So what you will do is that you will use states instead. And I would say that most of the time you should use RPL prop and not use the RPC save and load. But sometimes, of course, you will want to use RPC save and load for a very specific thing. If you have something very, like for example, this RPL prop, what it will do is that it will send all the variable that is replicated, like that has RPL prop. But imagine that you have like two variables, and one is replicating, saying like, oh, should I replicate? And the other one is not replicating. Or you want to replicate it only if the first one is active, for example, then you can do it in RPL save and load, because this is code. So you can be in RPL save and load. You can be like, if I find it again, you can be like, oh, if my get component here, I can do like, oh, if get component exists, and if my get component have specific flag, for example, then I will write something specific over the network. And then the same on the other side. This is mostly, like, this is very specific. Most of the time you will end up using RPL prop, and RPL prop, of course, is faster because it's using C++ behind the scenes, so it will be faster than actually calling script and doing script. So that's the thing. Yeah, we have so we have specific behaviors. We have the amazing, if we go into replication class, we have this, for example, is server and is client. And as it says, it's not very modular, and you should almost never use it. This is very like, if it's debug code or anything, you should use more like the ownership proxy model we said before, that we covered before. We have also another thing. We have this thing here, which is like find item ID and find item. So we will go a bit deeper on how the replication work, but it's still simple, I would say. When you create a component and you put an RPL prop, or you put an RPC on it, or you put like RPL save or RPL load, it will actually synchronize over the network. So if you don't put anything inside the component, it will not synchronize over the network. because of course we don't want to send all the component and the entity. Almost 90% of them doesn't need to be replicated. So we replicate only the one that we want to be replicated. And as soon as the component have one of those, it will get inserted into the replication. And when it gets inserted into the replication, it will actually get an RPL ID that we name it automatically. So the replication will give him an RPL ID. And this RPL ID will be associated to the component. So you will probably ask, like, why I wouldn't need that? Most of the time, we can try it. For example, I will write something quickly, but most of the time, what you want to do is that, for example, you have a component and you want to have parameter which is another component. Like, for example, I have door component and I have a particle component on my entity, and I want to reference this particle component or this other particle component on other entity, and I want to send it over network because I want from the server send a message to the client and saying, hey, do something on this specific thing. So what you will do most of the time, the easiest way to do it is to actually, if I find it again, because I can't find it, RPCs. So here what you will do is that under RPC, here you will not send only the percentage, for example, but you will send the RPL ID, order component. And here you will do like a RPL ID, replication, find item ID, and you will pass the item. So in this case, we'll pass ourselves. That's fine. So we find the RPL ID, and then we send it over the network, saying, hey, I send this RPL ID over the network. Then the client, what it can do is that it can be like, hey, find item, and find item will actually, you need to pass the other component ID, use call find item, and this will give you a manage other component. And this we can actually cast to selves. So we will have at least something and not like just manage, but you can cast this. And then, so then we do this. And then we'll put a breakpoint here. We will reload. And this, what actually happened is that you, yeah, I just need to move this here and put this here. It's fine. So usually you use it to reference other entities, for example, because you will use the RPL ID of the RPL component, because of course RPL component is also an item which is replicated, a component which is replicated. So you will also like use the get the RPL ID of this RPL component, send the RPL ID over the network, and then on the other side, on the client or server, you will find this item based on the ID. Of course, as I said at the beginning, we are on clients, we are streaming in only entities around the player. So if you, for example, on the server, you get the RPL ID of something opposite side of the map, and then you send to the client, and then the client tries to find this item, it will actually return null because this item is not streamed in to the client. It doesn't exist on the client at all. So it will just return null, and you can have issues like that, or you can have like a... So here, we'll do it again. Here, we'll set the debug custom to 777, and we'll start it. So this is one of the most like use cases that we will use to, for example, send entities over the network, like send some reference over the network or something, like you will use exactly this. Yeah, I just need to do this and it should be fine. So I will just go into debug Workbench, but I need to open the.
And you can use the other console, you know, like the hidden console. Oh, you got kicked. Oh, you have 2 games open.
Yeah, I have 2 games, that's why. I would just play again because I have 2 games. So here, script editor. I'll debug the client.
Yeah, but you need to call the RPC.
Yeah.
Remember, you have the other console, so go to here to like, the main world. Push this.
Yeah.
And use that console.
Yeah, I don't. It's hidden feature in Workbench is that actually you have a console, remote console, which is not in the script editor, and it's automatically like on at the bottom here, and it's hidden. Like you can't, like you need to open it to actually see it. So that's why. But we will use this one for us playing.
You press enter.
No, it's just that
it might be the other order.
It's not the correct door I placed, so that's why. This one I must place. Okay. So we have the door. We'll go here, presenter, and here we'll see that we have this happen. And if we look at other components, you can see that we have reference to ourselves currently, but like it can be anything. So you can use this to actually send over the network stuff. Yeah. We almost did everything today, actually. The only part that you will probably ask, and I will try to reply as much as possible, is how, if we go back to Eden, and we were saying like replicated entities, you know that in 1.3 and even before, a lot of fences, trees, a lot of those are like, there are a million of them. Like in Everrun, there is almost like 1 million tree placed on the map, tree plus bushes. And we don't have like 1 million replicated trees on the map because it will be impossible, and it will probably take like 4 minutes to load it into a game, and it will lag and everything. So how are we doing it? Like how can you replicate entities in this specific case, like trees, without having them replicate, like having the trees itself replicated? To achieve that, we actually using something else, which is if we look at the special map, I have the special map of like 10 meters, so it will be difficult. But you can see the trees are not replicated. So what we do actually is that we have some specific entities that are created per cell. So in this case, in each cell, or here it's like a very small cells, but I can restart Workbench with the correct like number. It will be easier to see. But in each cell, we actually creating an entity which will manage the replication of those entities inside the cell. So instead of having, I don't know, imagine 1,000 of trees in one cell, we actually have one entity replicated, which is managing those 1,000 of trees replication. So the state of the tree, blah, blah, blah. We use it because, of course, we can't have million of them replicated, and you should never have million of entities replicated in the game. The fewer, the better, of course. And no, I don't want that. And that's the most case. You will probably ask how we actually replicate those, of course, because as we saw, we use RPL IDs to actually tell, send over the network some specific, like it could be entities, but it could be component, but you use RPL ID to find the entity on the other side. But here in this case, we don't use RPL ID. So what do we use? And for that, we use entity IDs that you probably know of, I hope. If not, it's like an ID that is specified for each entity. So you have like IDs, which is on the map itself. And you, of course, like if there's entities that are spawned during the match or during the game mode, then it will have some IDs. But the specific thing of those entities ID is that if those are entities placed on the map, they will be the same between client and server. So you can use, instead of sending RPL ID, in this case, you can just send an entity ID over the network. And this will actually, you will be able to find it on the other side. But I just want to be sure that it's only map entity, so it's on the map. And also, they can change if the map is updated. So you can't use them for saving, for example, game mode state, and you save it into like JSON file, for example. You can't use them to actually to save it into JSON, because if the map is updated and the map added more entities, the entity ID are regenerated. So you can't use them to save. It's only use them for the session, like for the current session. So that's what we mostly use. Like if you use a green map, we have like one, we name it regional destruction manager, which if you look at it, you will find it. And we spawn it one parcel, and it will take care of all the replication of those entities inside the cell. Also at the start, I didn't say, but when you enter or when you replication distance enter a cell, everything will be streamed at the same, like everything in the cell will be streamed. It's not like a radius around you, like a sphere around you, but it's like a sphere which is intersecting those cells. And as soon as you touch the cell with this sphere, it will actually replicate everything in this cell. So it's also like another principle that we use for this this destruction of, it's not only trees, it's almost a lot of things, but that's what we use because we know that as soon as you touch the cell, everything will be replicated, so everything you will see. So this is why, for example, if you have a very long distance, if you hack in and you hack a very long distance, you connect to a server, you will see like trees not destroyed far away, and if you come closer to it, it will actually destroy. But normally you should not see it because like the fog is blocking it. So yeah, I think we have gone over
load time.
Yeah, we also have specific, we can go over like another specific thing of replication, which is load time and runtime entities. As I said with entity IDs, if entity is placed on the map and is replicated, it's actually load time, which means that for replication, it will be able to handle the replication differently. One of the most important thing is that currently, if For example, I will take an example of this building because building is easier in 1.3. But for example, this building, it's replicated. It's load time because here in RPL state override, it's none. So by default, it's load time if it's spawned during the map creation, and it's runtime if it's spawned not during the map creation, so afterwards. And when they are load time, those entities are replicated as soon as you come close to them. So if I see a building far away, for example, I spawn like here, like here in Gravite, for example, and I walk over here in Saint Philippe, and I see this 2 kilometers away, I see this building, and then become from not destroyed, it will become destroyed instantly because it will get replicated in. And then I go far away. When you get streamed in, like if you get streamed in a load time entity, it will always stream anywhere in the world. So if I got streamed in this building, it will be destroyed, and then I go far away, I go at the opposite side of the map, and this building become, I don't know, repaired, for example, or the change has changed, I will actually get those changes as well. And this is mostly why you have like this PL state override here. You can say runtime. But in this case, if I say runtime in this building, that means it will not be spawned during the loading of the world. So this building will not be here. And when I will come closer to it, it will actually spawn. And then when I go away, it will actually despawn. So if, for example, you have, you know, disconnect the view distance between like the replication distance and the view distance, you will not see the building far away, and then when you will close to it, you will see the building. So most of the time, you don't want those big buildings to, you know, be runtime because you don't want them to spawn when you come near them. You want to be there all the time because they are very big things in the world that you can see far away. Yeah. Yeah, there is also like a very specific thing is that if you are owner of an entity, it will never get unstreamed from your client. So for example, in the game, we use player controller, which is like a class, which is an entity which is spawned on the client, and this entity gives the ownership to the client. This is mostly what we use for communicating between client to server. As I said before, the you can only send RPCs from client to server if you are the owner. So in the game in Reforger, we actually use player controller to actually do that. So the game will spawn like some entity, which is the player controller. It will give the ownership to the guy. So there is like one player controller per player connected to the server. And then we use this to actually send RPCs over. Of course, there's also the character that you own and a few other things like vehicles. But player controller is one of the things that we use the most to send like information from client to server. And if you are the owner, of this entity, it will never get streamed out. This is typically, you can see it like, for example, if you go, if you have debug camera in Workbench or in Diag, and you like go away with the debug camera, like opposite side of the map, your character that you're controlling will still be streamed into you, like it will still be there, like it will never unstream. So the thing that you are owner will never be unstreamed. We also did not go over like this specific thing, which is like streamable. As I said, like you have like the special grid map. So if the entity is inserted into the special map, that means if you are by default settings 2 kilometers away, it will stream out, so it will be deleted from the client. You have also the other thing, which is like say, hey, I don't want my entity to not be streamable. I want it to be always streamed to everybody. Most of the time in Reforger, we use it for managers because those like entity that you don't care where it is in the world. You just want it to be synchronized to everyone. And that's how you do it, is that you can say to streamable disabled. So this will mean that this entity will be streamed to everyone at the same time, anywhere in the world. For other properties, we will go over in the next session. Of course, we have like replication advanced, and this is more advanced. You should not touch them if you don't know what they do. But those are very specific, so most of the time you will let it by default. Like this streamable is kind of the thing that if you want to create a manager, you will actually want to disable it. So that's mostly it for this session. We almost gone over everything for simple replication. Of course, always replication is very difficult. There is always like a lot of edge cases and everything. So in the advanced replication, we will try to go more deep into replication and how exactly it's replicated and what you could do and everything like that. But yeah, that's the end.
Thanks, Remy. Thanks, Mario, for this session. As you may know already, the next bootcamps will be again on replication. So Remy and Mario are going to go deep in the topic for a more advanced session. Thanks everybody for your participation, and see you next time. Bye.
See you guys.
Bye.